Okay. And now, next up is we have the Yaesu G450. And this is the G450A. It doesn't come with the DIN connector, computer control, or anything like that. And this one, when I got it, it had that bad analog board. And what happens, and you'll notice when yours does go bad, is that you can't calibrate the high side anymore. It just will not calibrate correctly and on the 415 degree setting for this particular controller. Trying to get the cover off here without killing myself. And there are those that probably would wish that I make the mistakes. Just trying to slide the cover off. It sticks. There we go. And what I wanted to do is if we can get to our little bench cam again, we can show you the rebuilding of this thing. There's our little Nano in there, and you can actually see him flickering on the lights. Make it darker so you can see the lights flicker. So he's actually communicating with the PC. And we've got our interface, and you can see these are the stock wires that go to the original analog board. You could replace this board with an original analog board right now. Go back to the way it used to be. And then we mounted two little relays right behind the front cover. This is to drive our left. These are paralleling the left and right switches. Yeah. Okay. And you parallel the left and the right switches. And of course, we've got the motor. Now, what's different between this and the CDE rotor is this is driven by its own little motor and its own little sensor. So not only do you have the rotor turning with its position sensor, you have this turning with the position sensor and the two track. So you have to actually have two blocks of code to make this thing work. And that's what makes these so interesting, because back in there you can see the little geared system and the pots and stuff a little bit over. Okay. And you can see our position sensor. We have to tap in off of all of that. And those of you with a Yaesu rotor, I highly recommend doing this. That connector is a pain. It gets loose. It doesn't connect right. It's got these tiny little pins. What I've done, and I'm not going to disconnect it because you lose everything, I have done with a twist lock connector. I've got like a 7-pin twist lock in here. That gives me a firm, solid lock, and I don't care how bad Tom walks across the cables and kicks it with his feet. It's not coming loose.
We all kicked the cable tonight.
Yes, ma'am.
Why don't you just slow down with the camera so
Okay.
we can actually see more?
Okay. I mean, we're already at 9 o'clock, man. We're going to be here all night. Hey, it's fine with me. But anyway, this is the G450. And now you will also see, and Freddie, if you don't mind, kick me over. Well, let's keep it like this. And what we're going to do, I'm going to put this down. And you can see, now we've got to get it closer. How about that?
Okay, that's good.
And what we're going to do is we are connected here with our Ham Radio Deluxe. And we're just going to go to 280 degrees. Yeah, we've got our rotor over here turning, and I've actually marked our degrees, and then we stopped a little bit there, and we are right at 280 degrees. And I'm sorry for the reflection. Let's see if I can't kill the reflection a little bit. But then all we got to do is we want to go to you can't see the PC, give it up. We'll swing back to 102 degrees. And you can see that we're actually tracking. And you can see, even though this motor is not synchronized with this motor, they're actually pretty smooth transition. And we should be stopping here pretty soon. There we go. And the PC says we're at 103 degrees. We asked for 102. It's going to have a 1 to 2 degree tolerance. So that is the G450 rotor. Go ahead and bring me back to the big camera. And that's our little G450. Any questions in the chat room? Or so?
We need to take a 5-minute break.
You want to take a 5-minute break?
Yeah, let's
Okay, let me answer this one question from a 9M2SQL. The Arduino Uno is only a 16 megahertz processor. To do the bit and data slicing you're going to want for an SDR, you're going to want something on the order of a Raspberry Pi or something a little bit higher bandwidth. The Arduino is just not an SDR. It's a controller. It talks to things. It controls things. But when you start getting up into those heavy data calculations, you're going to want a bigger processor. You might be able to do some with the do, and actually I hope that we can get to that later on this evening to show you what some of the higher processor speeds can do. But I really don't think you're going to be able to get a good SDR out of an Arduino, if any. So, yes, and Batman, I have stuff other besides rotors. I've been saving some of the better stuff for later. Anyway, we're going to take about a 5-minute break, and we'll be back, and hopefully we'll have the table cleared, some new stuff. KM4FAM. The first book that our ARR did, the Arduino and Pickaxe for ham radio, has a bunch of APRS and Arduino projects. That's why I didn't do any APRS in mine, is that book pretty much had covered the topic fairly well. Anyway, we're going to take a few-minute break.